Um, Today we'll be finishing chapter 12, and if the time permits, we'll go for chapter 13. And over the weekend, I will be posting the quiz number 1 and exam number 1 for 1 week. Okay, guys? So this, you can expect this weekend will be posted until the next weekend. So you have 1 week to finish it. Okay, guys, so let's start. This is just a further of the reaction of these alcohols and phenols, correct? And the same thing with the same trend is thiols with the sulfur inside. So the phenols, as I said, is very stable, does not react as such like aliphatic alcohol or aliphatic thiols. So, but we can take advantage on this. This is hydrogen here. So the nitric acid will come from the nitro group from nitric acid. That's nitric acid. So this is nitric acid. So now the phenol is the nitro group will come and replace the H plus here, or take over the H plus, and the AH with this here, OH, correct, with the H here, here it is, we'll make H2O. So here it is, we'll make this one here, both of them make H2O, and the NO2, the natural group. So the name of this is 1, 2, 3, 4 nitrophenol. Because that's 1, 4, correct? 4 nitrophenol, because the position is 1, 4, so therefore we call this one here para. You'll see the name of para nitrophenol, meaning the same thing, meaning the phenol is a group number 1, and the nitro will come as number 4. Okay? Did I mention that we have para, ortho, and what? And meta. So if I have something like this, that's a phenol. If the nitro group 1 and 2, nitro group is here, that's called ortho, or just abbreviated O. If I have the OH is here, and I have 1 and 3, correct? This is NO2. The position is 1, 3. This is 1, 2. That's ortho, this is meta, small m. And this one here is 1, 4. Here it is called bara. So you have 3 types of position of the substituents on the phenol ring. Whether this ortho 1, 2, whether it's 1, 3, meta, or what 1, 4 is para. So further reaction of this, you can see here that the phenols can react with can be halogenated, and you can take all the hydrogens here and replace it with your bromine, like this one here, 3 bromines. So you can just, this is number 1, 2, 3, 4, 5, 6. So you have 2, 4, and 6 tribromophenol, the product out of this. This type of reaction is easier if you do it through radical mechanism. As again, I'm not asking any mechanism will not come in the quiz or exam. I'm asking about the concept itself, but no mechanism. So I'm avoiding any mechanism in the sense that's not the purpose of this introductory organic chemistry. When you go for advanced chemistry, go higher, then yes, you'll learn a lot of mechanism. They call it substitution. You get nucleify 1SN1, SN2. You get elimination. All those of reaction. You have a carbocation addition. All those mechanisms you learn it. But for now, for our time being, don't worry about the mechanism. We are not looking how does it look like, but we are looking what's the product will come out. So we have an insect here. This insect can defend itself by spraying this amount here. This compound, excuse me, this compound, this is called quinone. Anytime I have this one here is oxygen at the top, that's called quinone. And quinone is a very nice dye, organic dye. So we can use it for organic dye as well as toxic, animals can defend themselves with it. So if you have some substituents here, somewhere R1, R2, R3, that will act like, like a spray, like pepper spray, you defend yourself with it, similar to that. So if you have instead of oxygen, both oxygen here and here, that will be hydroquinone. This one here will be hydroquinone. Again, the quinones and hydroquinones are very good in making organic dyes, and it's very good to making some like pepper spray to defend yourself, and that's what some insects are producing in their body, correct? So here how to get from hydroquinone to quinone itself. So this is 1,4-benzene quinone, or just a quinone. This is called 1,4-benzene quinone, but just the word is, the word is this one is just a quinone. A quinone will be looking, as you can see, that's a ketone, because this is carbon here, is not an alcohol. This one here, this is secondary alcohol. Remember that primary alcohol give you to, when you oxidize this, oxidation, correct? You get it to aldehyde. Secondary alcohol, we mentioned that last time, will give you to oxidation here. You give you to ketones. That's the next chapter. And tertiary alcohol oxidation is not possible. Oxidation here is no reaction. So those are very important type of reaction. The aldehyde can further go oxidized to carboxylic acid, However, this one here is taking what I'm oxidizing this one here, secondary alcohol. This is process called oxidation. Because secondary alcohol oxidation will make what? Give us what we say? Ketone. This is a ketone, or a double ketone, correct? So anytime I have a secondary alcohol will give us ketone. Primary alcohol give us an aldehyde, which can be further oxidized to carboxylic acid. Tertiary alcohol, no reaction. Now, if I go this way, can I get the other way? Yes. Those are here. This is oxidizing. Those one here, this is oxidizing agent. Oxidizing what? We are using, because to utilize this type of reaction, which is dichromate, Cr2O7. That's the oxidizing. Now, if I use a reducing agent of lithium tetrahydrogen boron, for example, this compound, this is reducing. This is reducing. So then I will have the reaction will go which way? The reaction will go the other way. So if you are reducing, you are producing back to this. From this, back to this. That's a reduction. Correct? So, but from the other side, from this here to this, that's we call oxidation. So you can see, you can get a quinone by oxidation of hydroquinone, correct? However, I can convert the quinone, the ketones, back into secondary alcohol by using a reducing agent, okay, which is lithium tetrahydrogen boron. So it's another compound. So this is another type of naming here. We have 3 tertiary here. It's methoxy, and here tertiary, correct? Tertiary alkyl group, 2 of them, and this is here. This group here is meth, because that's from methane, correct? Methoxy. The group called methoxy. And here is tertiary butyl. Those 2 here. So those 2 here are tertiary butyl, and the whole thing is phenol. Then you can see, start from 1, it's your hydroxide, 2, 3, 4, 5, 6. So this is a phenol, and in position 2 and 6, you have tertiary, and then in 4, 1, 2, 3, 4, you get methoxy phenol at the end of phenol. So you get, everybody knows how to name this? Everybody knows how to name this? So, everyone? Okay, so your body or the main skeleton is phenol. So write the phenol is at the end. That's a phenol. It's an alcohol, aromatic alcohol. So now we'll start by numbering. This is number 1. Either or you can go, because those are tertiary butyl group. 2, 3, 4, 5, and 6. This is 5 here. This is 4. This is 3. This is 2. So you have 2 and 6. 2 and 6. Correct? So you have 2 and 6 tertiary butyl. And then somewhere here, you'll get what? Methoxy. So, comma, you have to tell me where is the methoxy. Number 4, comma 4 methoxy. And then at the end, the whole body is phenol. So you have di. Our D will come before the M. So we have to watch for the alphabet. So D comes before the M. Correct, guys? So our naming is correct. Our naming is correct. The D will come before the M. So 2,6 tertiary butyl dash for methoxy, and at the end is phenol. This is phenol. So that's the skeleton is phenol. So That's where you can name any organic compound. It's not difficult. The main thing, which one will take priority, which one will take first priority. So if I have an alcohol and I have double or triple bond, the alcohol will come and take priority. As you can see further, if I have an aldehyde next chapter, or ketone and aldehyde will take over alcohol priority. The body will, the whole skeleton will be designated as an aldehyde or ketone, and the OH from alcohol will be as a hydroxy group. Now, if I have a carboxylic acid, will take over the aldehyde and ketone, so the whole thing is carboxylic acid, and whatever group out of the aldehyde and ketone or alcohol will be named as a substituent group, correct? So you can, yes?
How do you know that CH3, 3C is a terbibutyl?
Well, the only thing you can know when you take it apart. So you have 3 CH3 connected. This is C here, correct? And you have 3 of those. So 1 CH3, 1 CH3, 1 CH3. This type of drawing, you have 3 of those connected to 1 carbon. That's tertiary butyl. Why butyl? Because you have 4 carbons, correct? Those are 4 carbons from butane, correct? But now we have all those connected to 1 of them. Therefore, will be what? We're a tertiary. If I replace one of them out, for example, this is tertiary. So this is TRT, butyl. Now, if I replace one of them with hydrogen, that's, we are dealing with another group. So CH3 and H, see, that's connected to the ring. This is to the ring, connected to the ring or whatever. This is isopropyl group. So this is tertiary group. This called isopropyl. Yeah, make yourself go and look in the, if it's not in the ebook, you can Google those groups, isopropyl, tertiary, correct? So those are always, if you replace it with 1 hydrogen. If you have it a group, another methyl group, whatever, that will be tertiary, because tertiary means you have 3 carbon groups connected to what? To 1 carbon. If you have 2 groups like here, connected to 1 carbon, that's a propyl. And then the word for the iso, because they are bent. They come like this one, bent in the molecule, correct? So you don't, so just the naming of this one here. So it's an example here. A skunk is, that's a very typical animal that gives off thiols, and or we call them mercaptanes. The commercial name of the thiols called mercaptanes, and they stink. So it protects itself, correct? It protects itself by spraying this type of very, very bad smelling compound, thiols or mercaptanes. Sometimes the commercial name or the common name of thiols, anything thiols, anything related are SH. Anything with this is a thiol. All, because we are replacing the OH. Remember the OH? OL at the end? That sounds like alcohol, but the thio means what? Thio every time means, in organic chemistry, means sulfur. So that's what the skunk is doing, is spreading. And the name, the common name is mercaptanes. Mercaptanes is a lot of organic compound, depending on the R you have. They smell very bad. Are we doing this like the skunk? Yes. Somebody had eaten bad food, and the enzyme inside the stomach could not really digest it very well, and we have sulfur in our body. Yes, some people, when they eat some special food, they start forting a very bad smell. Not that skunk level, but very bad smell. The farting coming out of their body is so bad you cannot sit nearby that person. You have to get out. Are you following me here? So farting is part of producing those mercaptans, those thiols, correct? So not everyone, that's specific, some people, especially if you eat some sort of food that has sulfur inside, okay? So that's, and the skunk is really farting, as a matter of fact. But farting is a very concentrated thiols and a very comprehensive thiols. The R here is too big for the skunk, too big, correct? And that smell even very bad. I worked through my life, that's about 38 something years in Kansas. That was my master's degree with mercaptans. And my kids and my wife at that time, 38 years, they couldn't really smell me very bad. I have to put all the clothing out and everything outside the house because it smells very, very bad. It smells very bad, and you have to have it under the sun. So the sun and the wind, and if there is rain, will take care of the smell. It takes over 1 week or so, 10 days, to get the smell off of your clothing, correct? So it smells very, very bad. And those are called mercaptans. Now I was using some of the, they call it military-based World War I mercaptans. Those even very comprehensive, and they smell very, very bad. They stay for several, some of them for several days, 10 days, 12 days to get out. And they have to stay out of the house because otherwise the whole house will smells very, very bad. Even worse than the WC itself. You can imagine. WC smells bad, but those mercaptans even worse than the smell of the toilets or bathrooms. Very, very bad. So, but if you're hit by a skunk, you know how does it smell. It smells very, very bad. I'm telling you up front. So, here it is. Those thiols, they have similar reaction like alcohols. The S is oxygen. However, we know there's oxygen here. The same behavior, but the oxygen is more reactive, more electronegative, and the oxygen is more reactive. So the alcohol, I can expect the alcohol to be more reactive than the thiols. So sulfur is less electronegative, so it will be less reactive than the oxygen. Oxygen start to pull electrons from the adjacent atoms. So the alcohol in general very active compared with the thiols. I mean, oxygen we don't have. You can look at the periodic table over there. First, the top is oxygen. Immediately, the second element underneath oxygen is sulfur. However, sulfur is not that reactive as oxygen, correct? So what will happen here, the same thing with oxygen, the same thing with sulfur. S will come here, the whole group, the thiol group will come, will take over the X here, and then the X will be by itself, and there. This is minus here, SH minus, correct? So the minus here is thiolate. So this is thiolate ion. So we have a thiolate ion with the minus will come and attack the halides. That's called the halide alkyl halogens. This is alkyl group. This is alkyl halogens. Halogens means chlorine, bromine, iodine. So called alkyl halides, the name of it. And X can be bromine, can be chlorine, can be iodine, those three. The fluorine is not stable because it's most electronegative. So those are the three ones. X can be those one of those three ones. So bromine here, chlorine, bromine, iodine. So meaning the iodide, the bromide, the chloride. Okay, guys. So that's the reaction of the same thing with the alcohol. The alcohol will react the same thing, but it's more aggressive. The alcohol will react the same way. However, the reactivity is more, because we have oxygen is more electronegative. So we can expect the alcohol more reactive than the thiols. Okay, guys. So that's how to make those thiols. How to make those thiols. Okay, guys. So the thiol, because we have this OL, because it's similar to alcohol. The thiol is sulfur, correct? And this is very similar to this OH, but the OH is more reactive. So, and this is here just to look at the, those are amino acids, guys. And those amino acids you have in the membrane, I mean in the cell membrane, those type of chain is connected by disulfide. This is biochemistry. You will learn about them later on. The disulfide means two sulfur group connected to the main chains, and that's sort of like a cysteine, and this is like an enzyme. This can act like an enzyme, or we can build more than this. We can transfer this one here to hormones. Hormones and enzymes are produced in the liver, and their production is very similar, depending what you have. Those sulfur bridge, they call them bridge because they are bridging between chain, and they are really acting like stabilizing the structure, So that's a cysteine, amino acids. Why is amino acid? This is an amino acid. This is carboxylic acid here, and this is the amino group here, and this amino acid called cysteine amino acid. And the sulfur bridge is used to stabilize this amino acid. Somebody will tell me where we can see those type of amino acids. Amino acid, guys. Somebody? Any knowledge about where to find amino acids? Where to find it? Our muscles. Protein. The protein is, another word for protein is what? Protein is a combination of many amino acids combined together. Are you following me here? So what is protein? Protein is amino acids, combination of several amino acids. So the protein is very, very crucial component in formation of muscles. So, and we need amino acids. Where we can find amino acids? We'll come back to that later on, carboxylic acid. Where we find amino acids? Don't let me down. Where? And muscles, yeah, but where? We need to eat it. Not everything comes inside the body manufactured. The liver, manufacture almost a lot of stuff, a lot of hormones and enzymes. But you need to help the hormones from outside. Amino acids found, which is healthier, in the fish. If you eat fish, remember you eat amino acids. Correct? A meat has amino acids, but the amino acids connected with a lot of junky fat, junky cholesterol. Are you following me here? It's not, the amino acids is eating from the meat is not really recommended, because you not eat amino acids free like it comes in fish. The fish is really, they have free, less cholesterol, less fat, less all this junky stuff. So now this type of plant here, we want to see the structure of it. So I want you to write, and then they say the structure of it is 2-isopropyl 5-methoxyphenol. Can we draw this? Yes or no? Yes. So what is my skeleton here? What's my skeleton? The core and the backbone of the whole molecule is what? Phenol. That's this one here, correct? Perfect. So this is my skeleton or my core or whatever you call it. I'm trying to make it so it looks nice. It is. This means what? Delocalization of the triple double bond. You cannot localize them, so therefore they are moving around the ring, correct? So this is our skeleton or backbone, whatever, or core. Some textbooks we're using skeleton or backbone of the molecule. So whatever you name it is the same thing, depending what book you are using. So it's a reference of the author, but that's the main one. That's we have here. Now, this is the numbering will take over what? By the OH. This is the main thing here. So we'll come here and say, this is my 1, this is 2, this is 3, this is 4, this is 5, this is 6. 2-isopropyl. Did I mention isopropyl? CH3. CH3, correct? And it has 1 H. If I have replaced the H with another group, will be what? Tertiary. Will be what? Tertiary. But we have what here? This is isopropyl. We just mentioned that a couple minutes ago, remember? Now the 2 is isopropyl. This group here with the H, 1 H. But if I replace the H with CH3, another group, that will be tertiary butyl. So this is isopropyl. Okay, guys, this is isopropyl. Then we have 5-methyl. Where's the 5? It's here. And what is it? Methyl, correct? So CH3. So we have this, and that's our. This is the plants here. And this is the formula of the plants. Whatever it's producing is producing this type of, and this is antibacterial. I remember a long time, Adam and Eve, when they came from the heavens down to the earth, there were no hospitals, correct? How they treat themselves. So all the pharmacy you can see, 100% of the medicine they found, its roots in the plants, believe it or not. So the whole pharmacy stuff here is a plant chemistry. It's a plant chemistry. The plants can produce a lot of good stuff as well as highly poisonous stuff. Are you following me here? So a lot of good stuff and a lot of bad stuff. So some trees are producing highly poisonous chemical compounds. Okay, and thus you can see some of the flowers you can smell, but some of them you cannot even touch because they can give off vapors of highly poisonous chemical compounds. So, but anyway, so at least you know that's pharmacy is nothing less than just chemistry of plants. That's my opinion, my preference. That's what I say to other I have some friends, professors in pharmacy, but I tell them that all your stuff is related, and that's really true. Whatever we are manufacturing, you can find it in nature. You can find this one in nature. But what the difference in nature and manufactured by humans? Somebody will tell me? In nature, you will get what? Less side effects. Because you don't have to have these preservatives inside. It comes naturally. So anything drugs or medicine extracted directly from a plant, you can expect this drug or this medicine to be least side effect. You will have at least, or you have almost some of them zero side effects. However, the ones produced by human, it has, because we add a lot of preservatives to keep it, from decomposition or whatever, so or reaction among itself. So therefore, you see, I would say most of the medicine or drugs or coming from human or human made, they have a lot of side effects. Okay, guys, any question? Now we'll go for ethers. Ethers is nothing less than just ROR. So this is R1, this is R2, and the oxygen in between. So this is the least reactive compared with what? With alcohol and thiols. So alcohols, phenols, and thiols are more reactive than the what? Than the ethers. This type of settings here of the groups are called ethers. Why ethers is not that reactive? Well, it turns out oxygen is not free. Like we have a thionyl, sulfur here is free. It has only what? H unconnected to R, correct? And the OH is free, connected to H and here R. Are you following me here? R can be benzene ring, for example, can be benzene ring to be phenols. However, this one here, what we have here, we have replaced this R here by another what? R. This makes restriction on the activity on oxygen, and therefore even the polarity of ethers cannot compare with those two. Are you following me here? You are restricting, especially if R is too bulky, too big. Those two here and here, if they are too big, that ethers will be solid at room temperature, and is very, very, very low in reactivity. Does not react. Are you following me here? Chemically, I'm speaking about chemically. So the presence of two R groups, depending on their size, will limit the reactivity of ether. So we can't expect ether to be active or reactive such as alcohol or thiols. Because alcohol and thiols, they have a free hydrogen. They can really, it's easy for oxygen to move around. Sulfur is easy to move around, and the reactivity will be high. So that's one of the reasons ethers are not reactive. Ethers are not reactive. So now, ethers cannot make a hydrogen bond. Those, they can make hydrogen bond. So both of those here, they can make hydrogen bond, correct? We talked about hydrogen bond before, correct? Did we talk about hydrogen bond, guys? Yes or no? Yes. Hydrogen bond, you have to have two molecules. The first molecule will deliver the hydrogen. The second molecule will deliver what? The hydrogen. So if you combine them together, one of them will have the, or with H2O, for the solubility of H2O. They make hydrogen bond with H2O. But here you cannot. Those are connected to carbon-carbon. You don't have. If you combine them together, they can't. If you can combine even H2O to that, they can make hydrogen bond with the hydrogen here, only if R is small. Hydrogen bonding soluble in a very small type of ethers, if R is small, such as this one here, CHOCH. That's the smallest one. So that can make a hydrogen bonding with H2O, so the H will come here, OH, correct? So the hydrogen bond will come from, H2O, and the oxygen from what? From the ether itself. Now, if you have bigger than this here, tertiary butyl alcohol, whatever huge R here, so that will not work. There will be no hydrogen bond. Are you following me here? So those R's are restricting the reactivity of the oxygen here in the middle. So how we name this? Well, you have in the PowerPoint, the name of it is not real. The name of it is common name. But let me show you here, with the help of this, how we name ethers. CH3, OCH3. That's what you have inside your PowerPoint. As I said, those PowerPoints not done by me, so I'm using the ebook PowerPoint. However, this is called dimethyl ether. You have two methyls, and this group, functional group, is called, this here, oxygen. But that's a common name. Anytime I have the ending with the same group, functional group, that is common name. Aldehyde, ketones, phenols. At the end, if I have it, then it mostly will be common name. What is the correct one? You choose the longest chain here of the carbon, but they are identical here, correct? So therefore you have this one here. What's the name of this group? What's the name of this group? Come on, don't let me down now. What do we call it? That's a methyl, correct? Meth, and this is oxygen, methoxy. So I have added the oxygen to the methyl. Methoxy, and this is one carbon. So the name of this common name, dimethyl ether, is methoxy, and one carbon is methane. Correct, guys? Let's name another one. You tell me. Here it is. Can I take this one out? I'll take it out, and I will have another one. Let's put here CH3. This is an ether. However, the other group is made of so what's the name of this? Well, we can add more. We can add more, but 3 is okay. 3 is okay. We can add more, whatever. So what we call this, what's the common name first? Common name has to end up with ether, correct? Ending with ether. So what we call this? Well, look at this, guys. This is a methyl group. That's the ether block. So this is methyl group, correct? And this is what? What is this? How many carbon we have? Propane. But propane is alkane. Take the N out, add YL. That's a propyl, correct? That's a propyl, that's a methyl. From the alkanes, methane, take the ANE out, so we are going from methane, correct? ANE, take this one out and replace it with YL. That's a methyl. And this is propane, 3 carbons. Take the ANE out, add YL. That's a propyl. So, which will come first, the M or the P? The M. So, our ether will be looking methyl, okay, propyl, and the common name we have to add its functional group. Methyl propyl ethane. Well, that's not correct when it comes to the IUPAC real name. Well, what we have to do in this, we have to calculate how many carbons we have at the side of both oxygen, of both sides of oxygen. So this side I have 1 carbon. This one how many? How many carbons? 3. So the longest chain of carbon will win. So this one here will win, will take over. So this one here will be, this is IUPAC here, International Union for Pure and Applied Chemicals. This will be propane. This is an alkane. And this is now, because of this is a propane here, and this will be methyl oxy. So we have what? Methyl oxy. Methyl, or sometimes called methoxy, sometimes without the L. But I like to have the L because that's methoxy. They said methoxy. The L is out sometimes. So, but anyway, so that's the way we can name those. Everybody's following? So first you name, see who's the two both sides of the of oxygen, which one has the longest chain. I named this longest chain as a alkane, and then the other one, the oxygen with the other one will be what? Will be as oxy. Correct? Now, sometimes any question about this? Sometimes very strange, enough strange that you have the phenol is hooking up itself. It's an ether, but it's so what do you name this ether? What's the name of this ether? So what's the longest chain here? The phenyl ring is not the longest chain. It's a substituent here, correct? It's not the longest. You can't count this one as 6 carbons. No. We said the longest straight chain. That's what we are always, longest. The condition is longest straight chain. So how many carbons? Here we have none. None. Just 1 carbon here maybe. Correct? Really 1 carbon. So say carbon is 1 here. So carbon is, you count, carbon is 1. Is this one here. Connected to oxygen. How many here we have? 1, 2, 3, 4, 5. So what do we name this one here? What's the name of it? The IUPAC name. But we can, what's the common name? Well, this one, a common name will be phenol, correct? And instead of L here, take the L out, and not double O, phenoxy. Double O, we always get out of double vowels. We have 5 vowels. Anytime they are redundant coming together, just write one of them. We don't write 2 O's, okay? So, phenoxy, and this is a phenoxy group, correct? And this one here is what? Phenoxy what? Ethane? No. Pentane. Thank you. Pentane. Okay? Phenoxy, pentane. Perfect. Thank you very much. Now, can we that's IUPAC name. How about common name? We need a common name. What's the common name, guys? Well, the common name, it turns out, this is by itself phenoxy. This will be what? As a group. What will be? Come on, guys. Will be what? Pentyl, correct? Will be pentyl. So this is phenoxy. This is the whole group. So the PE will come before the PH, or the PH will come before E. Which one we have to write? Now we have PP, both of them pentyl. The whole group is pentyl. We are looking for the common name. The common name, we look at them as substituents, as groups. So this is pentyl and this is phenyl. Which will come first, the E or the H? The E will come first, then the H. Okay, so that will be bentyl. The PE will come first, and then bentyl, then phenoxy. Phenoxy, then you add what? Ether. That's a common name. It is. Phenoxy ether. That's a common name. Can you see the difference between them? Sometimes the same alphabet, the P is, but then we have to take the second alphabet. If they are both first the second, we take the third alphabet. We have to take first priority to the whoever comes according to alphabet first. So we have two of them here, and then therefore we have to take the one that comes first. So that will give you the naming, which is very difficult, I think, understood. Let me just take this one out. And now, with this in mind, we can expect, as I told you, the boiling point of the ethers are very low. That's we explained to that, correct? We did explain this. It's the fact that oxygen is not free. It's connected to R. R here, oxygen is really restricted from reactivity because of the R, and depending on how big the R is, reactivity will be even less and less and less. Correct? So that's, we talked about this. No hydrogen bonding possible between two ethers. If you have two ethers together, you cannot make out of them R or R. You cannot make of them any hydrogen bond. No hydrogen bond. Correct? But with H2O, it's possible. Possible with H2O if the R is small. If the groups attached to the oxygen is small, then there will be hydrogen bonding. If this is too large, then the hydrogen bonding will be not available either. So those are ethers. Somebody will tell me, well, I'm going to the second, where we use ethers in the past. Not now, but in the past. Somebody will tell me? No? No idea? You should know. You will be working in the hospitals, correct? A lot of you will go for nursing or something, pre-med. Correct. In order to get some people to sleep really long time, not even better than the chloroform, the small ethers, they will keep you asleep for hours. Are you following me? Depending how many milliliters you are taking out of this. So they put people sleep long time ago, but now they have much more articulate chemical compound than the ether itself. Okay, but they used for keeping sleep, so keep the people sleep during the surgery. Correct? So the naming, we went through the naming, and we went through the naming, common name, and this is the naming here, guys. As I said, the smaller the group, the more reactive the ether is. So this is more reactive than this one here. Here we have 3 carbons. Here we have 1 carbon, 3 carbons here, and here 1 carbon, and here is 2 carbons. So this is more reactive because the R, so the smaller the R, the more the oxygen can move around and be reactive. But this one here, less reactive. And the name of the common names, you end up with ethers. So this is dimethyl, because this is here, will be dimethyl ether. This one here, you have methyl, you have ethyl and propyl. The E will come before the P, so ethyl propyl ether. So, and with this here, we can look at the last slide of this chapter. Yes.
Can you repeat what you just said? You said the more or the less reactive or the more reactive?
The more bulkier R is attached to the oxygen, the less reactive the ether is. The more bulkier or bigger, say so, if that's bulky, maybe bigger, the bigger R is, the less reactive the ether is. The smaller R in size, like 1 carbon, methyl group, for example, the more reactive the ether is. Okay, guys? And that's really for the whole chapter, thiols and alcohols, if they are connected to big R, so you can't, this is the same trend, but in ethers you can see it much better. So if this is here R and SH, and then you have R, OR. Now those two here, same thing. If the bigger the R, the less reactive the alcohols and phenols and thiols. Are you following me here? So the alcohols and thiols will be less reactive if you have bulky R, huge. When I say bulky, you have something like this, not tertiary, then it goes like this. Go further than this. So you have a huge group, and those groups really restricting, hindering the molecule to move freely. Are you following me? And the activity will be very less reactive. This molecule is not reactive. Chemically, it's not reactive. So here's the same thing. The higher the R here, size in size one, the less reactive the molecule. And we compare those here. This ether here is more, dimethyl ether is more reactive. That's a smaller one. This is the smallest ever smallest ether. Why? We have 1 carbon here, 1 carbon the other side. 1 carbon both sides of oxygen. So that's not bulky, not bigger one. Now here we have 3, and we have 2 at the side. That will be less reactive. That will be what? Less reactive, chemically less reactive. So, saying this, going to the last slide here. The last slide, the chemical reactions of ethers, as I said, it depends on R. If R is smaller, then the chemically will react, correct? And it reacts the same thing, like similar to the with the highlights, similar to the alcohol and thiols. But in general, they are not really reactive, and especially if they have bulky R. So here it is, when over time ethers can react with oxygen to form hydroperoxide. So, well, if you have an R here, and then you let it per time, they can react, you get something, a peroxide. The oxygen will come in, invite itself here. Oops, sorry. Then you have something looking like RO, it's a peroxide here. So peroxide. But if you let it react with that's from the air. But if you put the heat beside it, then you can't combust it to carbon dioxide and H2O. So the main reaction of it of ethers is with halides. X can be, here it is, X can be Br, or can be chlorine first, can be bromine, can be iodine. Not the fluorine is too reactive because, so those are the acids, strong acid. HF is a weak acid. So those are, they give away their X, correct? So the X will come and take over here, and the whole thing here will come itself with the H. So here it is the swap, this double displacement reaction. The H here will come and take over the X will be OH here. So here it is. and the X here will come and take over this. So you get alkyl halides, and you'll get an alcohol out of those. So ethers can be converted to alcohols through a halide reaction. Okay, halide reaction means H. So or acid here. That's an acid here. HBr, HX, hydrochloric acid, hydrobromic acid, iodic acid will come and react, and the cleavage will be here. The cleavage, the breakage of the molecule will be here. The molecule turns out to be broken, cleaved by this way. So the X will come to this way here, and the H will come to take the other side. That's the only reaction known. And the peroxide, ethers can go to peroxide, as I said. That's well known in the lab, by the way. So if you keep the ether open in the lab for a while, then you make out of this peroxide. And if the weather is coming warm and you have no refrigeration, they start what? The cleavage again will go here. They are highly explosive, but it's not that bad. But we put them in the fridge, and you see the fridge is popping, dancing because of the explosion of the peroxide. They are not stable. If you have no cooling system for them, they need a very cold environment. Otherwise, they will break. They will cleavage back. So they will break, and then you get a lot of explosion out of them when they are breaking. So this is chapter 12, and 10, 11, 12 I put over the weekend. Quiz 1 and exam 1 covers chapters 10, 11, 12. Let's do chapter 13. So chapter 13 is aldehydes and ketones. So aldehydes and ketones is, as I said, believe it or not, let me just get the Microsoft Word. Take this one out. Well, the aldehyde and ketones comes in many fruits, by the way. So most of the smells of the odor of the fruits, whenever I smell the fruit, I can tell that I have a ketone or what? Aldehyde. So the good thing about aldehyde, you can recognize them from smell. So aldehydes and ketones, they are characteristic with their smell. So, for example, ketones is acetone. Don't tell me you did not smell acetone. So, I think you have painted your house or your place one day, and you use that, they call it paint thinner. If you have a thick thinner for sitting for a long time, you want to use a solvent, you use acetone. You smell the acetone, correct? So now, the aldehydes, I would say apples, the smell of apples, pears, I would say most, not apples, but all the fruits, I think, all fruits, if I'm not, you can check it, all the fruits, they will have a smell, and this characteristic smell, unless that fruit has no smell, but even, I would say all the fruits, they have distinct smell. That's the opposite to that's the fruit. The veggies, on the other hand, some of them, they have no smell, and therefore they might not have what? Aldehyde or ketones, because that's the way I can, from the smell, tell if I have an aldehyde or what? A ketone. The alcohols, like we have them, except for thiols, they stink, forting, Alcohols, some of them, ethanol has a smell, methanol has no smell. Most of the alcohols have no smell. But the aldehydes and ketones, they are very distinct in their what? In their smell. So how the function groups looks like? Well, it's good. Can't cover a lot of stuff. the functional groups of aldehyde, you have R and C, H. This functional group called an aldehyde functional group. And then before I start using the PowerPoints, and this group here, R, C, O, and then R prime, or R1 here, R2 here, R2, this is ketone. This is a ketone. And if you can recall, this coming from the oxidation, primary alcohol oxidation, will deliver you what? Aldehyde. Secondary alcohol oxidation will give you what? Ketones. The tertiary alcohol, what we say? There is reaction or no reaction? No reaction. Just to let you know this, you can remind yourself from where we get those aldehydes. Well, it turns out that the primary alcohol oxidation can result in aldehyde, and with this functional group, C double bond O, H. The secondary alcohol, they give us a ketone, R, the same like two R's and then connected to carbonyl. This one here, this group here, called, it has a name, distinct name here, carbonyl functional group. So, and the common name always end up with aldehyde or ketones. The other one is always what we are naming them towards their alkanes. So let's look at the naming, and then we'll go for physical properties. So naming, we have still, very good time. So naming, I have the symbol one here is C double bond H, H. Well, it turns out that the IUPAC name will tell you the number of the carbon is always will depend, will really put this is a functional group here, correct? This is a functional group. And this functional group, according to the IUPAC, has to come up with AL at the end. AL, not OL. OL for alcohol. This is AL. Because it has one carbon, is one, that's what? Will be what? Methane, correct? It is. Let me just write you for the, this is methane. One carbon is methane, correct? Take the E out, add what? Al. This is methanol. What? Methanol. Take the E out, add Al. That's the system. That's a real chemistry name, IUPAC name. That's a real name. Now the commercial name, because it has one carbon, I said it's formaldehyde. Form, because it has one carbon. Carbon is one. This is formaldehyde. Remember, we common name always will end up with the functional group, and this is called here common name. Correct? Somebody will tell me where you use formaldehyde. Somebody is taking A&P. Somebody has seen in A&P lab, biology lab, dead cats preserved. Somebody has seen it? Okay. So formaldehyde is mixed with the ethanol to make a solution called formalin. So the mixture of formaldehyde with alcohol makes a compound called alcohol ethanol, correct? So if you add ethanol to this, so if you mix those together here, this plus this one here, you make a compound called what? Formalin. Formalin is a very excellent preserving mixture, or preserving combination of a mixture of alcohol, ethanol, and formaldehyde or methanol, correct? So that's what you use mostly the formaldehyde for. We use it in the lab a lot because we mix it with the we don't mix it, we buy it as is, as a formalin, but we know that we can prepare it in the lab, correct? You can prepare it in the lab as well. So mixture of formaldehyde or methanol and with alcohol, that make the solution that's really helping preserving dead bodies for a long time. Why is this preserving? Well, it turns out the alcohol has a distinct characteristic. It will kill what? Bacteria. Therefore, at home, in the kitchen, you have to have rubbing alcohol. Somebody will tell me what rubbing alcohol is? That's a commercial name. What's the rubbing alcohol? What's rubbing alcohol? It turns out rubbing alcohol is secondary alcohol. 2-propanol. 2-propanol called the commercial name of it. 2-propanol, commercial name called rubbing alcohol. It's used to kill, if you have a cut, and it's better to have some rubbing alcohol inside your kitchen. You put some rubbing alcohol or 2-propanol, the OH is the second carbon, 1, 2, 3. So it kills all the bacteria. And that's the same thing with formalin. Alcohol is a very good compound that kills bacteria. You add it to formaldehyde, it will keep this body out of any bacteria intervention or intervention or eating up this dead body. So the bacteria will eat up this body if there is no formalin. So, but that's a rubbing alcohol. That you have to know what rubbing alcohol is. So the commercial name is RUBB, rubbing alcohol. So if you'll find it in Walmart, find it in any pharmacy, and rubbing alcohol or the IUPAC name is 2-propanol. That's the OH is in the second carbon. Okay, guys. So now let me now come up with other bigger ones, and you tell me how we name this, and then we name the ketone, and then we'll stop. So here it is: CH3, CH2, CH2, CH2. Okay, C, O, and then here H. So what we call this? What we call this? One, always that's your 1, 2, 3, 4, 5. So IUPAC name goes by the alkane. All the time alkane is our reference. So that's bentane, correct? Bentane. So take the E out, add to what? Al. I put it here. That's because I can replace the hydrogen with groups. Then you can number them according. This is number 1, and then whatever here substituents will come here. But that's the whole thing is called pentanal. I'll stop here, and then we'll go and see the ketones. But what is the common name of this before we common name? What we call this? What we call this? How many carbons we have? 5. So always you add up what? Okay, so this is your bentane. So here you have, take the E out, correct? Then you have here pentane. Okay, so pentane here, take the NE out, add pentylaldehyde as a group. This the whole thing here is a group, and this group called what? Pentyl, correct? Attached to the aldehyde functional group here. So this is pentyl, what they call it, pentylaldehyde. Okay, guys. So this one will be, the common name will be just pentyl, because 5 carbons, and then you'll end up with the aldehyde as functional group there. But the idea is the IUPAC pentane, take the E out, add Al instead. So I'll stop here, and I'll load the whole thing.